Hello everyone, welcome back to my channel. So today I'm going to talk about graph traversal. If you've heard terms like BFS and DFS and you still get confused, this video is for you. Alright, so let's start easy. So before going into graph traversal, let's get a small idea about what a graph is. So think of a graph like a bunch of points connected with lines. Those points are nodes and the lines are connections. A graph can be directed or undirected, weighted or unweighted. You actually see graphs in real life all the time, like Facebook friends, Google Map routes, stuff like that. Now, let's go to graph traversal. Graph traversal just means how do we visit all these nodes without missing any or repeating them. This is used in searching and pathfinding. And for that, we mainly use two techniques. The first one is breadth first search, also called as BFS. And the second one is depth first search, DFS. Let's talk about BFS first. So the easiest way to remember BFS is like checking your surroundings first. Imagine you're in a new place. So first, you look at everyone around you and then you move further away. That's exactly how BFS works. It goes level by level. This is an important thing you need to remember when it comes to BFS. It goes level by level. That means it visits all the nearby nodes first and then moves outward. Behind the scenes, BFS uses something called a queue. Basically, first one in, first one out. And also, one important thing about BFS is if you're trying to find the shortest path, BFS is your best friend. So now, to understand BFS, let's see how it works. So first, you need to start from the source node or the root node. And then you need to visit the node and mark it as visited. Add all the unvisited adjacent nodes to the queue. Repeat until the queue is empty. So this is how BFS actually works. So as you can see in this graph, the exact way to go from node to node is like this. You start from level 0. So this is level 0. And then you go to level 1. You complete all the nodes and then you go to the level 2. And then you visit all the adjacent nodes. So that's it. If you have understood how BFS works, let's look into this example. So in this example, as I said before, BFS goes level by level. So in level 0, we need to start. So in level 0, there is the root node, which is 5. So you start from the node 5. And then you need to visit all the nodes at the same level first. So after level 0, the next level is 1. And then you need to visit all the nodes in level 1. So which is 12 and 13. And after completing that, you need to go to the next level. So in the next level, the nodes are 7, 14 and 2. So after completing the nodes in level 2, you need to visit level 3. So in level 3, the nodes are 17, 23, 27, 3, 8, 11. So this is the answer for the given graph. That's it. You need to remember only in BFS, it goes level by level. So I hope you understood about BFS. So now let's go into DFS, which is the second method. DFS is the opposite vibe. So instead of looking around first, it just says, okay, let me go this way and see how far I can go. So DFS goes deep into one path. It keeps moving forward until there is nowhere else to go. And then it comes back and tries another path. This is why DFS uses a stack or recursion. A good example is a maze. You keep walking forward and when you hit a dead end, you backtrack. So, to understand DFS, let's see the working. So, it's the same as BFS. The first step is you need to start from the source node or the root node. And then you need to visit the node and mark it as visited. So move to an unvisited adjacent node. You need to backtrack when no adjacent unvisited nodes exist. You need to go in a specific path like this. You need to first complete this path and then this, and then you go to this path, you finish that, and then finally the other adjacent node which is not visited. I know it sounds confusing, but it's also easy, just like BFS. So in this example, the root node is 5. Then you need to complete the path first. So the next node is 12, then 7, then 17. So now the first path is completed. Then you can go to the other adjacent node, which is 23. Now after you complete this path and this path, we can go to the next path. So in the next path, the node is 13, then 14, 27. Then you go to the other path, which is the node starting from 3. Now after you complete this path, we go to the other path, which is 2 and then 8. After completing that path, finally we go to the last path, which is node 11. So that's it. This is the example for DFS and also for BFS. So you can see how these two differ accordingly. So this is the answer for the DFS example. A simple way to remember between BFS and DFS is BFS wide first, level by level, DFS deep first, one path at a time. Neither is better than the other. It really depends on what problem you're solving. So let's see about BFS and DFS differences. BFS uses queue, while DFS uses a stack or recursion. BFS goes level-wise traversal, DFS depth-wise traversal. BFS finds the shortest path, while DFS explores all paths. BFS, it uses more memory usage, while DFS uses less memory usage. So, where are these used? You might be thinking, okay, but where do we actually use this? BFS is used in things like shortest path algorithms, social media connections, web crawling, and so on. While DFS is used in maze solving, file system, detecting cycles, and also topological sorting. So yeah, these aren't just exam topics. They're actually useful. So just to wrap this up real quick, graph traversal is about visiting all nodes in a graph. BFS explores nearby nodes first, level by level. DFS goes deep into one path first. As I said, both are super important, especially if you're into data structures or coding interviews. That's it for this video. Thank you for watching.